Let's see, my name is Tim Antonowitz, and I am with Mosaic Technology, and my Twitter handle is at TimAntz. I am the senior architect and engineer at Mosaic. We are a VAR, value-added reseller, out of Salem, New Hampshire, specializing in virtualization solutions, etc. We have two offices, one in Salem and also one in Bellevue, Washington, just outside of Seattle. So I get the joy of flying back and forth across the country all the time, and I get a lot of frequent flyer miles out of it. So that's about it. And they have really good coffee there. Basically, what this presentation is, I believe it's called The Next Big Thing. And my premise here is that most people have virtualized their data centers. Virtualization is a great thing to consolidate your infrastructure, make it more highly available, more responsive, easier provision, etc., etc. But most people stop there. And one of the reasons is virtualizing your data centers are for you. Makes your life easier, better uptime, easier to provision, simpler, less hardware to deal with, all those other things. Makes your services more available and responsive, but the biggest benefactor is you as an IT administrator. In most cases, starts to give your life back a little bit, so you don't have as many issues to deal with. But there's a lot more things you can deal with virtualization than just consolidation. That's pretty much the big thing. The other part is I love whiteboarding. And almost 2 years ago, I gave my last PowerPoint presentation. I hated giving PowerPoint because as I'm up here flipping through slides, people in the audience grab their phone and they're checking their email and texting and stuff, because they can just look up at the slides, see what they want, and go back to their own business. And it's boring sitting in a PowerPoint presentation. Delivering them is just as bad, if not worse. So I tried to break out and do something different. So we started by doing a presentation and no slides, just put up a couple whiteboards. And I just started talking and whiteboarding. And first time somebody asked a question, I had them repeat it. And I said, well, went over to the whiteboard, started drawing out their question, their diagram, and what they were talking about. Started offering a solution right there. Well, what if you did this? What if you did that? And they were like, wow. So all of a sudden, everybody put down their phones and started looking, paying attention. Somebody else asked a question about the same. Well, what if you did this? Well, good. If you do that, and started working through it, giving detailed information. And all of a sudden, everybody went from reading their phones and playing around to leaning forward in their chairs, watching, focusing, finding out what I was talking about, because it became more interactive, engaging. Ever since then, I have not done a PowerPoint presentation. It became problematic when we had physical whiteboards, and then you didn't have a whiteboard, or we were traveling or doing stuff, makes it difficult. So I had an iPad, and I said, well, I whiteboard on my iPad. And I got an Apple TV and plugged it into the projector and then just did AirPlay to throw it up, and it worked fine. But Apple TV doesn't work with VGA. And it had another thing I had to carry around. So I found a new application called AirSketch, which put on the iPad, and it actually turns this into a web server. So I can connect to the IP that I have here, log in and authenticate just using a web browser on my laptop and put the projector onto my laptop. So everything that I do just comes onto a web page. If I'd open that up, anybody with a laptop or whatever that was on the same network could see the same thing. Really cool way to whiteboard without a whiteboard.
You saving anything?
I am. Actually, I'm running Camtasia. And so I'm doing a full screen capture. So as I do, it's going to be a big movie. Additionally, in AirSketch, as I make drawings, and I draw out, 3-node cluster, shared storage, vCenter out here, do all that basic stuff, I can save it to my photos or save it as a PDF before I erase it. So doing it two ways. I'm just, as I draw diagrams, I'll save them, but also I'm capturing it as a movie, and we get a recording today. So you're all in Candid Camera. So getting back to the original presentation, this is more about what to do next with your virtualization. Where do you want to go? Virtual desktops, disaster recovery. And there's a lot of options, whether you want to go to the cloud, what is the cloud, what levels of cloud protection you have, and the ways to get there. Where are you in your environment? Are you virtualized? What part? What are you doing?
Well, no, I'm a consultant, so
okay.
I don't really get involved with what I have. But yes,
okay.
clients are obviously the data center are virtualized, and they're looking at cloud-type stuff, applications as a service.
Okay, absolutely, and that sort of stuff is very relevant now. What we're finding is cloud activity seems to be about the same place that virtual desktops were a couple of years ago. A lot of people are talking about it. Some people are starting to put a little toe into the water, so to speak. But there's not a lot of wholesale adoption of cloud services and infrastructure for their core services. They may have some outsourced application, whether they outsource email or something else to other services, because it's more cost effective for them, especially in smaller shops. But unless you have very large data center infrastructure and there's a large cost associated with that, cost-wise, it's not as easy to buy infrastructure in the cloud and push things out into a private cloud or even a public cloud infrastructure, because there are requirements based on bandwidth and latency and availability and stuff that cloud takes care of, but comes at a higher cost. If you're buying flat out ground zero, you want to go there, that's great. If you have a company who has data centers and hundreds of thousands, if not millions of dollars in infrastructure that they put in there over the last 10, 15 years, it's hard to just scrap it all and just buy from point one.
It's not just money, and most of your business critical applications
yes.
don't end up on the cloud.
It winds up, and some do, but it really depends on what level of performance is. If you have a high-end database and you really need a lot of number crunching and you need to be close to that data, it doesn't make sense to put it in the cloud. Unless your entire infrastructure is in a single solution and you as a consumer are only seeing, say, a web front end, that's one thing. Yeah, but if your delivery is a big problem there, it does. Is it viable? Yes, but in most cases, you're going to need a huge pipe, and your latency may or may not make it worthwhile. So it really depends on how you consume and how the application functions. If you have a largely distributed application, and you have multiple instances running concurrent and in parallel, that may be a good solution for a cloud. But if you have just a monolithic database or data engine or something like that, maybe not. And like I said, it's not just the data, but where the processing happens. It's getting to a point now where the processor engine isn't, in some cases, isn't the limiting factor. It's the data gravity, so to speak. You have so much data in some cases, it's too inefficient to move the data to the processor. It becomes more efficient to actually move the processor to the data.
I'm smiling because I told a student that was the solution to his problem a couple of years ago.
Yeah, and it's actually becoming, in cases where people are using a lot of, say, Amazon or cloud services with big data. Everybody says big data, but I mean, you have a lot of data that you're crunching in some sort of archive and everything. If you're moving that data to a service to process it and work it, moving the data becomes more cost prohibitive than moving the application closer to the data and work, closer in that instance. And that's somewhere where it would be a good case to virtualize everything, put it all into a cost-efficient cloud, as long as it's in a contained area and not distributed.
Well, IBM pushes a lot of that in business intelligence, because you're dealing with big data and it's just a lot of crunching.
Right.
You need the horsepower that
Exactly.
IBM can provide.
Do it out there where you can ratchet up that as you need it. But the sense of like having your data in one place and processing it in another, that sort of cloud activity may not be the best case, simply because bandwidth and latency become a problem. But I mean, that's just one case of what the next big thing is, or whatever. It's virtual desktops. In the last session, we talked a lot about virtual desktops, especially in an academic environment. We have several customers who are actually going to View because in their computer labs, they're seeing that the large amount of applications they need to support, the applications get bigger and bigger and more complex, and they need to cohabitate on that big lab image with academic software that's 10, 15 years old that has never been updated, but the professor requires that for a specific class. And compatibilities are becoming more and more difficult to put everything into a single image and have it coexist.
What are you seeing as the break-even point in terms of when the investment in VDI outweighs an investment in traditional workstations? Like how many does it take for it to really make sense?
That's a really tough number because
for like an office kind of a scenario, not, I mean, that academic example may be
right,
different.
and I say it's tough because it's not necessarily the number of desktops, it's the size of the organization and the IT staff that needs to support it. Because if you have an instance that has 50 workstations out there, and you have 3 IT people, of which one does system, networking, storage, backup and recovery, all that stuff, and you got 2 help desk guys that just run around and help desk, fix this, go change, do this, all the minor stuff. I'm having a problem with printing. I can't get this font to work, or stuff. Doing much more help desk oriented stuff, and you have one person who's doing most of the heavy technical work. In that case, you may have more of a challenge virtualizing these 50 desktops, specifically if these help desk people aren't looking to increase their skill set. Because even though a View infrastructure will make managing these individual desktops much easier, from an administrative point, because they're all base images, they're not residing on physical hardware, they're back in the data center. There's a lot more resiliency involved there. the complexity of these people's jobs becomes more, because now they're not just managing a Windows environment. They need to understand the relationship between a user workspace back to a virtualized instance, and how to recover, how to deal with more on the system side of things. Whereas if they don't do anything other than just the desktop still, and they're not involved with any infrastructure, the workload on this person increases tremendously, because because the desktops are now a systems infrastructure.
So you have less help desk tech and more system admin.
Correct. So if you've got,
Who are typically more expensive than help desk tech.
yeah, if you're looking at help desk techs who are, all they want to do is help desk, they're not looking to increase their skill set and step up the ladder, so to speak, it can be a challenge. But if these are young guys right out of school who want to learn, or are very aggressive and interested in learning more solutions, well, here is a learning path to be more involved in how systems work in the back end and their relationship to the front end. So dynamically, it's not necessarily the cost of software and storage on the back end versus individual desktops. It's more of a human resources cost. This becomes much harder to justify unless you have the right set of people. In cases where we have small places, we've done rollouts of 50, 20, 100. And it really depends.
Atypical there?
Uh,
Aside from the issues you mentioned.
Atypical. In most cases, you're looking to do 100 as your first rollout. 50 is kind of on the long side to make it cost effective on just a purely balance sheet sort of thing. Then 100 is more effective, and that's usually a single rollout or whatever. There are also growth possibilities there. If they say, we're going to do 50, but I have 3 other offices that I need to do as well, and we can show that.
Subsets of users or applications that you might start with, if say you have like 500 desktops?
As part of a rollout, we usually like to pick and choose the right pilot group. Because as part of a rollout, you are learning it as well as your customers. You're getting more familiar with dealing with all this infrastructure. And if you couple that with a select group of users that are the squeaky wheels, so to speak, that, the people that call all the time because they have problems, you never get those. But I mean, if you select those people to be in your test group, your results may be skewed because of the user pool as opposed to the actual functionality of the system. It's much easier to start simple and add complexity as you become more familiar. In the case of some colleges that are doing virtual desktops in their lab infrastructure, they're starting with 50, 100 desktops or so in 2 or 3 physical labs. They're building a base image or a couple other ones based on student pools or application pools
So
or
in that kind
whatever.
of situation, there's no persistency in the desktops, really, right?
There can or not. It depends. There's both ways you can do it. Depending on what the use case is, if you have a whole bunch of random students that just come into a place and they just want basically a generic workstation environment where they're going to work, and when they log out, you want to wipe it and reinstall basically, and so the next student that comes has a clean image, you can do that. Absolutely. It's very easy to do with View, because basically that virtual machine that they're working on, it'll work similar to as if you threw away a snapshot, but to revert back to before the snapshot, so to speak. And that's the end result of refreshing that desktop. So next person that logs in gets a clean desktop environment. You can do that non-persistent. You can use the persona applications there to redirect that user experience to shared storage. So basically like similar to roaming profiles. So when they log in, it could be a generic non-persistent desktop, but when they log in, they get their desktop.
From the last session.
From
Keep-
their last
keep the
session,
brand
because
nice, and of course, in the computer labs there, sometimes you want the computer set up for the specific course you're
Yep.
teaching. And that's what you can do. Okay,
Yep.
between these hours, and people logging in will access
Yep.
this image, and somebody else will access that image, or that
Right.
the student comes in as just an open lab and will do some work, and then can log off, and you're saving what he did, because he can go to another lab, log in, and just recreate what he had been doing.
right. And what we're doing in those cases is we can build specific images for different classes and courses and entitled users based on their Active Directory credentials. Say, every student who takes your class is in an AD group that's named after your class. Well, everybody in that department, I mean, you could have an image based purely on your software and your image, or every professor in your department, they may pool all that software into one IT,
As a department.
one department image that has all the different software. Every student who's taking any class is in those individual groups, which winds up in one group that all IT course students are in that. Well, you can entitle all IT students to be entitled to the IT image. So when they log in at the desktop, they could see generic kiosk desktop, IT, and they'll pick whichever one they want. They would just do regular work, they're doing IT work. Well, if they're also taking a biology class, in that list they may see the biology image.
Could be key to the password.
Exactly.
Key to their
You know, so,
password.
and usually, right, that usually rolls back down to Active Directory. So just by integrating the student records information into your Active Directory. So if during add drop, you have the student list and you know their class, you just script the creation of an AD group that has every student in there. You just automatically update it from Banner or whatever application they're using. It's all up and running and working fine. Student adds and drops, the next day they're in the right group. They're automatically entitled to go into that lab and have that image.
Sometimes licensing gets to be a challenge, I would imagine.
Right, and there are ways around that, because you could say, okay, I can't guarantee that, you know, I have 10 copies of this software. Well, I want to put it on 10 machines. Well, you can do that. You can only limit that pool to just 10 concurrent connections. The 11th, you may have 11 sites. The 11th person to log in won't get a machine because there's none available. So they have to wait till somebody logs off, and then they can log in. The next logical step to doing something like that and virtualizing those labs are, once that's done, you don't necessarily, because it's virtual, you don't necessarily have to go to that physical lab to get that software. What if you open it up to all of campus? So they could go into their dorms and have access to the same lab without having to walk across to the computer lab. So they're doing homework or they're doing other things. It's available everywhere on campus. Extend that out to distance learning or, you know, online classes. If you're delivering online classes to a student and they need this software, well, if it's already in an image and there's a virtual desktop access through View or whatever, why wouldn't they have credentials? Because they're a student, they'll have a domain account. Why couldn't they log in through a security server and have that remote desktop from their house?
You have bandwidth issues with that. But,
Right, and that's acceptable in that paradigm. It's much better than if they need this software, have it available for them to download or burn a DVD and mail it to them and have that installed on their desktop. And then the help desk gets the call, well, it's not working on my laptop. I don't know, go through the process, come to find out their laptop's 6 years old and just physically can't run it. You know, well, if it's 6 years old, they can run the View client and have a remote Windows 7 session that's with, you know, 2 gigs of RAM and fully capable to run that application. They don't need all that hardware at their desktop. Or if they have a Mac and they need Windows software. It's just a remote screen. So that's some of the capabilities that come out with virtual desktops that allow us to extend some of that stuff beyond what it is, currently in the physical world. And we have 2 or 3 colleges that are actually doing that right now. Interesting ways to, beyond, what virtualization was 4 or 5 years ago, and now we're seeing other use cases. The other world is disaster recovery. As you know, when you virtualize, all of those files, all the pieces of your virtual machine are simply files. If you put those on storage, within there you'll have VMX, VMDK, several other files, but basically they're just files. That virtual machine and those files can run on pretty much any industry standard x86 server. So it doesn't have to be that physical server in your data center where it's installed right now. If you have an ESX host somewhere else, you can take those files, put it on storage in another location, fire it up, and it'll run. So when you virtualize, you're already 80-90% DR proof. It's just a mechanism of figuring out how to get from point A to point B, turn it on, and make it work in that environment.
Can you just give a little overview of what the different ways of accomplishing that mechanism are, SAM replication, is anything built into VMware, third-party tools, and in what situations they might make more sense than the other, bandwidth requirements,
Yeah,
automation.
sure. No, not a problem. You have your data center, and this is like one of my favorite pictures because it's really generic, but it works. Some hosts, shared storage. Your VM is on shared storage in a cluster. It could be on local storage, but in this paradigm, we'll talk shared storage. Well, in another site, you may have another cluster with other shared storage. So you have 2 paradigms. And this storage could be local as well, but it's just storage attached to ESX hosts, vSphere hosts. This virtual machine, by the nature of being on vSphere, hardware independent for the most part. If it'll run vSphere, it'll run your virtual machine. There may be, whether you have enough memory or whatever, doesn't really, but the architecture is pretty much the same. This could be HP, Dell, IBM, even a lot of white boxes will run vSphere, it'll run your virtual machine. Same over here. For examples, we'll go HP and Dell. Just pick a couple customers, basically. 2 data centers, host, virtual machine. In order to get this virtual machine to run over here, all you really need are those files. There are a couple mechanisms you can do. First is storage-based replication. You can take a LUN, replicate it at the storage level, and have that same LUN in both locations. Usually asynchronous, but depending on how much you want to spend, you could get it synchronous. That's really a factor of a lot of money. But you can do it asynchronous. Changes that happen at the block level in this LUN will be transferred to this LUN. This doesn't care whether it's VMware, whether the virtual machine's Linux, Windows, whatever, don't know, don't care. It's just changes of blocks of data on one LUN will be transferred to the other LUN.
So how does that replicated LUN on the destination side present to the vSphere hypervisor on that end? Does it just see it as a data store?
What happens?
Just sort of being updated under the hood and VMware doesn't know? Or?
Well, what happens here is because within this LUN you have an actually formatted container which has blocks. Well, the actual format there is blocks written to disk as well.
Right.
So that comes over here where you create this LUN which by default when it's replicated has the container, has the formatted pieces and all of the data.
I guess what I mean is what does VMware see? I mean, if changes happen
Right.
and are replicated at the block level.
Right. This would be offline, so it's not available during a replication. It's a replica, so to speak.
Because otherwise the
When
file
it-
system could be changed.
Correct. When it becomes active and you decide to change it from replica and make it active and mount it, these hosts will mount this just as if it was another LUN,
Right.
the other location. If you have a LUN here that's offline, you bring it online and mount it, you'll say, oh, it's formatted and here's a bunch of files in it. That's
And
what
say
happens
that-
here.
Say that LUN had 5 VMs on it.
Yep.
And you really only wanted to recover one of them.
All 5 would be
They're all
there.
but
They're
just
all there.
You add it to your inventory and boot the one.
Yep, you would go in, you would browse the inventory, figure out the one you wanted, double click, add to inventory, start it.
How do you automate that at the VMware level?
Site Recovery Manager. That is storage-based, VMware-based disaster recovery. Site Recovery Manager is a couple different pieces. First of all, there's an SRM server, which you can, depending on the size of your infrastructure, put it on a dedicated virtual machine. You can put it on your vCenter server. It's really small, and you're looking for resources. SRM. It's a service, integrates into VMware as another tab, just another piece of virtual center from a management perspective. There's also a piece of software called the SRA, Storage Replication Adapter, whatever it means. The SRA is a piece of software written by the storage vendors. Dell EqualLogic writes theirs, Compellent writes theirs, EMC writes theirs for their different tiers, HP, NetApp, they all write their own SRA. This is an application that has hooks
So that's ensuring data consistency.
right into the API of the storage device. And vCenter and the SRM service interacts with this. What happens is when you want to know, say I want to protect server A, which is a virtual machine. Well, through Site Recovery Manager, you pick your server. It knows using this that server A happens to be on this LUN. And because you've already set storage-based replication, you know that the SRA knows that that LUN is replicated. Well, there's an SRA on this end too.
So if you want to replicate some VMs but not others, you're best off bundling them onto maybe 1 or 2 LUNs that do it, so you're not replicating the data you don't need more space on the other side.
Yes. At the storage replication level, it's important. Virtual machine placement is very important because you can have multiple LUNs that have different replication rates and cycles. You could have, just for example, you can have 3 volumes, 3 data stores, and one replicate every hour, important data, one once a day, and one once a week. It's really static, non-critical stuff. If I lose a week's worth of data, so be it, or whatever. once a day keeps track of some other stuff. And once an hour is some very important data that you don't want to lose more than an hour's worth of data.
How can you measure how much bandwidth, because obviously every situation is different, that you would need? How do you measure how much bandwidth you would need to do something like that?
It's a lot of trial and error because it changes based on your change rate.
Right.
The data may be very important to have at least an hour's worth of replication.
And we're talking about changes at the block level, so at the VM
right.
file
Block
level, there may not be that much block
right.
because you know there's data changing.
Right. If data is changing, you need to move that data within that time frame. If it doesn't change frequently, but you need those changes. I mean, you can be down to 5 minutes if you want, or something like that on most async. But it's based on the change rate and how much data you need to move from point A to point B. So if you have a very high change rate, you have to push more data, you need more bandwidth to get shorter times.
Suppose you could build your replicated site in your primary site, get a number on the transfer, and then at a small scale.
You can. In a small scale, that would work. For example, if you're looking at two small arrays that have replication, be it EMC, EqualLogic, HP, whatever vendor, just a small site, you can enable replication locally so that initial seed happens, because the first time you replicate anything, it has to send all the data. Next time, you're mostly just going to send block level changes. So that first push, if you can do it locally, that saves a lot on your bandwidth. And then if you run it for a while, you can find out trending-wise how much data you're actually pushing every hour, every 15 minutes, every day, or whatever. Because chances are it's going to fluctuate, but if you do it over time, eventually you're going to get a good profile of what your change rate is. Then, with the knowledge of what your change rate is and the amount of data you're going, you can calculate out what your bandwidth requirements are going to be to get, 5 minute, 15 minute, an hour, whatever, and then say, okay, well, I would love to have every 15 minutes, but the cost of bandwidth is prohibitive. I can only do once a day.
So your schedule,
Your schedule is really based on that. The other factor is you can look at other possibilities such as WAN acceleration, which will optimize some of that stream so that you don't send, not only sending change blocks, but you'll only have to send unique change blocks in some sort of caching mode, so that your bandwidth, even though you have, say, 5 megabits, it may act like 20 megabits, and you get better performance pushing that replication traffic. And there are several products that can do that really well.
and what's the failback scenario?
Well, failback would mean, hang on a sec, if you have data in one site and you're pushing it to a second site and you have this much data and you're doing on a regular basis, failure happens, you are now writing new data over here. Well, in order to fail back, this data needs to go over here.
Do you need to reseed everything?
Well, it depends on the storage provider and the functionality. If your storage provider retains that storage there, and then that's the fail back like that assumes that the failure occurred, but it wasn't a destructive failure.
Yeah. So it's just
As long as the data is still there, well, this hasn't changed, but all these changes need to come back. So if everything's intact and you're just moving temporarily and moving back, you need a mechanism to push those changes over here to make this current with that. If your storage provider allows for that failback, it works great. If it doesn't, or if it's destructive, and you start with a fresh new container, then everything has to go, has to be reseeded. And this can be hardware-based, be software-based, because not only is there storage level replication, SAN to SAN, or array to array, or whatever, there's also VSAs and the vSphere replication as well that take this into play. If you're using vSphere replication, that is very different from a architecture perspective, because that is done at a VM level, not a SAN level.
So it's doing the block level replication of the MBKs.
It's looking,
Block level.
yes. So vSphere replication appliance. There's too many acronyms, but basically, the vSphere replication looks at this on a per VM basis. Oh, I want to pull it. So, in the interface in vCenter, when you want to replicate, you select your virtual machine and say, replicate the virtual machine to my paired site. And you set this, 15 minutes, day, week, whatever. You set your replication cycle that you wish to have on that virtual machine. And then the replication occurs through the appliance to another appliance on the other side, and it sends the blocks or the change blocks of that VMDK and sends that on an ongoing basis, similar to what you would do. For example, if you've used Veeam to back up, backs up an image and then does change blocks and moves over. This kind of mechanism, similar sort of mechanism. It uses the mirror mode driver and a couple other things as well. But basically what it does is it changes on that virtual machine are then replicated to this other on a per VM basis.